Guys, welcome back to another final exam review session as we are on part 7 of these series of videos working through the study guide. Let's jump right into some example problems. Where we left off was problem number 50. It says given f of x is equal to x squared minus x and g of x is equal to 1 over x, complete each of the following. Write a simplified equation for h of x, which is g of f of x. So we have a function composition here that we need to complete. So we need to, this is equivalent to writing this as g of f of x. So we need to take f of x and substitute that into g for the variable. So h of x then would be 1 over replacing x with f of x, x squared minus x. Then it asks to list the domain for h of x. Remember, the domain for any rational expression, or rationally function here, which is a fraction with variables in it, is all real numbers other than zeros of the denominator. And so what I'm going to need to do here is I'm actually going to need to take h of x and I'm going to need to factor it. So I'm going to factor this into 1 over x times x minus 1. So the zeros of the denominator would be that x cannot equal 0 and x cannot equal positive 1. It cannot be these because if I put a 0 in for x here or 1 in for x there, the denominator would be 0 and the denominator cannot be 0. So x would exist within the real numbers except for 0 and 1. This would be acceptable notation. You could also write this as an interval, so from negative infinity to 0, not including 0, or from 0 to 1, or from 1 to infinity. So either way that you want to write that is okay. Now we want to evaluate h of 1 and h of 2. Well, we know that h of 1 is undefined because that is part of the domain restrictions. If we go back to the domain here, and I'll focus on less of the interval but more of just the expression that we wrote, any number would work except for 0 and 1, so I cannot substitute in 1. If I do want to find h of 2, I can do that through substitution. So this would be 1 over 2 squared minus 2. 2 squared is 4, minus 2 is 2, so 1/2. You could also substitute that in via the calculator to simplify. Taking a look at problem number 51, it says, in the space below, sketch a one-to-one function with the domain of x equals all real numbers. Briefly explain why your function is one-to-one. So remember, one-to-one functions have one output value to each input and one input value to each output. So we want to make sure that we sketch a function that represents that. And so you can really sketch just about anything you want as long as this function passes the vertical line test, which tells us that it is a function, and the horizontal line test. So let's make it a sentence. This graph passes the vertical and horizontal line tests. So vertical line test would tell us it's a function because we are checking to make sure each x value maps to only one y value. So if I take a vertical line here, let me get one up on the screen, and I drag it through the function, it intersects the function in one location only, meaning each x has one y. Then I want to go ahead and make this a horizontal line and do the horizontal line test, dragging it through the function, make sure that it intersects the function at one location at a time, meaning each y maps to exactly one x. So this is a one-to-one function. In problem 52, we are given f of x and we want to algebraically find the inverse of f of x. Remember, to find an inverse function, you can take the x and y coordinates and switch them. So f of x is technically a y value, so let's make this x equal to 1/2. The square root of the x now changes to a y. Now to find the inverse of f of x, I need to get y by itself. So I'm going to add 3 to both sides, then multiply by 2 on both sides of my equation. And then to get rid of the square root, I would square both sides. So y equals 2x plus 6 squared. And this would be an okay way to write it. If you wanted to complete the square here to complete the multiplication, we would square the 2x, multiply the two terms together, 2x and 6, which is 12x, and double that, and then square the last term. And this would be the inverse of f of x. So you could write it as the quantity squared, that would be okay, or you could write it as this expression. Taking a look at 53, now we are getting into some word problems. So problem number 53 says the function v of h gives the formula v for a rectangular box in respect to the height h in inches. Given the length of the box is greater than the width, factor the function to answer each of the following questions. So it says how does the width of the box compare to the height? So what we know here is that the height is h. The height is h, and we know that the equation v of h is 2h cubed plus 5h squared plus 3h. And we know that the volume equation for a rectangular prism, which this would be a rectangular prism, it says it's a rectangular box, is length times width times the height. So we can factor this by taking out a GCF. That would leave me with h times 2h squared plus 5h plus 3. And then we would like to factor this expression, which we can, by breaking the trinomial down into a binomial. The first term are going to have to be 2h and h that would multiply together to give me 2h squared. The second term is going to have to be factors of a positive 3, which would be 3 and 1. We want to make sure we put them in the right location, that through distribution, the combination of those two results would give us 5h. So this is going to be the factored version of the volume equation with respect to h. Now we know that h again stands for height. Another thing that it told us here was that the length of the box is greater than the width. So the larger of these two, 2h plus 3, would then be the length, and h plus 1 would be the width. So the question in A says, how does the width of the box compare to the height? The width is, let's see, our units is in inches, 1 inch greater than the height. So width here is h plus 1, or height plus 1 inch. B says, find the volume of the box if the width is 4 inches. So not the height, but the width is 4 inches. So this factor right here, h plus 1, represents the width. So the width would be 4. Therefore, the height would be 3 inches. So what I really want to find here is v of 3. And so I can go ahead and input 3 into the original function. I'll go back to the original function. 2h, or 2 times 3 cubed, plus 5 times h squared, or 3 squared, plus 3 times 3. So the volume of the box would be 108 cubic inches. Take a look at another example of a word problem, problem 54. It says a farmer sells eggs at the local market of the farmer sells eggs at a local market for $2.85 a carton. At this price, the farmer expects to sell 348 cartons each week. Each time that price is increased by 25 cents, he expects sales to drop by 20 cartons. The function r of x models the farmer's revenue. With respect to x price increases. Use the information to answer each of the following. A, determine the maximum revenue that the farmer may earn. So they gave us the equation here for the revenue, and I'm going to go ahead and sketch a graph for revenue. And on the y-axis, this is going to be revenue. This is the r of x equation. And x-axis, this is number of price increases. Okay, so if I sketch my graph here, I have a negative 5x squared plus 30x plus 991.8. So I'm going to have to manipulate my graph a little bit to make sure that I see what I want in my window. So I'm going to set my X minimum to 0. I can't have less than 0 price increases. I'm going to leave the maximum as 10 for right now and see what happens to the graph. Then I'm going to go to zoom and down to 0, zoom fit. And here I see pretty much the entire graph that I'm looking for. I'm actually going to extend the window a little bit more because it doesn't get all the way down to the x-axis. So I'm going to extend this out to 15. Now let's try this at 15. That's close, but still not quite all the way down to the x-axis. So I'm going to extend it out to 25, not 250. I'm going to extend it out to 25, and this is going to give me plenty here. And continue. Every time I adjust the window, the X values of the window, I hit zoom and then go down to fit. And I'm going to bring my Y minimum back to 0 because I'm not going to be concerned about negative revenue. At least most likely not in this case. So here's my curve for R of X. Okay, this one did not ask us explicitly to sketch the graph, but I went ahead and sketched the graph anyway. As you will find that graphing is going to be part of what you're going to be expected to do on the final. So part A says to determine the maximum revenue. Now, this is a quadratic equation, and it's a parabola that's opening down. We know that because the leading coefficient is negative. So I could algebraically find the vertex, or because I have graphed this, I can find the graph or the vertex by hitting second, trace, and going to maximum, the fourth option. It will say left bound, so I'm going to move my cursor over to the left of the highest point of the graph, the left of the maximum. Doesn't matter where, just make sure it's over on the left. So here it's right here, that's my maximum somewhere in there, and hit enter. Then it'll say right bound, so now I'm going to move my cursor back to the right side of the maximum, and then I'm going to hit enter, and then it's going to ask me to guess. I'm just going to hit enter. So the function will occasionally, depending on where you put your points, it will occasionally give you a slight rounding of the answer here. So this point is actually 1036.8 approximately. So it says determine the maximum revenue that the farmer may earn. So the revenue at this maximum point, so A would be approximately $1,036.80. And this is per week, as he's selling this amount every week. Now part B says, at what price should the farmer sell each carton of eggs to maximize revenue? Well, this graph does not give me the price. It gives me the number of price increases. So what I need to do is I need to go back to the original equation. If I want to think about, or the original problem, if I want to think about price with respect to increases, the price was originally $2.85 per carton. And then he's going to increase it 25 cents at a time. So 0.25x. Well, now I know to maximize revenue, x needs to be 3. So I can input 3 into this equation that I have set up. And this will tell me that a price of $3.60 per carton will decrease the number of sales, but that increased price will yield the highest revenue. Let's take a look at one more problem. In problem number 55, it says Alan wants to buy a small boat worth $7,250. If he has $4,600 to invest in an account paying 7.15% annual interest compounded daily, how long will it be before he can purchase the boat? Well, what we're looking at is the annual or the compound interest formula here. And so this would be P times 1 plus R over N to the NT power. This is not compounded continuously, but compounded a set number of times in a given duration. So we are going to start, or we are going to look for a total of $7,250 of value. That's how much he wants to have. Currently, he has $4,600, so that's going to be the principal. We know that the rate he is investing at is 7.15%. So when inputting that into the equation, I'm going to turn that into a decimal, 0.0715. This is going to be over n. And now remember, n is the number of times that it's going to compound in a period. So this is annual interest. So my period is in years. My time is in years. It's compounded daily. So it's going to compound 365 times in the year. So now I need to solve for n. So I'm going to go ahead and in my calculator do, I'm going to round this number in my calculator. Now I'm going to use that answer later, the decimal, but just to write it down, I'm going to do 1 plus 0.0715 divided by 365. Now again, I'm going to use this decimal later, but when I write it down, I'm just going to write it this as approximately 1.00. So if I want to solve, the exponent t that I'm solving for, so I want to get t by itself. So the first thing I'm going to do is divide both sides by 4,600. And this is going to give me a decimal that I'm going to approximate, so 1.57. Now again, it's an approximate decimal. Eventually I'm going to use the decimal in my calculator. So now I need to get the t out of the exponent. So I'm going to use a logarithm with the base of approximately 1. So that log base approximately 1 of this 1.57 is equal to 365 t. And then to get t by itself, I'm going to divide by 365. So this again is approximate as I've rounded my decimals. So log base of almost 0 of 1.57 over 365. When entering this into my calculator, I'm going to use the change of base formula. So the log of the 1.57, I'm going to input in here, which I should have been writing as 1.58, but I'm going to use that decimal, divided by the log of the base. I'm going to go back up and choose the decimal that was part of my base. And then I'm going to divide this by 365. So though I rounded the answers in my calculator, I want to make sure that I use those decimals to get my answer. So we're going to round things to the hundredths place generally. So it's going to take him approximately 6.36 years. 6.36 years to amass enough money to purchase the boat. This is all I have time for, so we're going to stop here. The rest of the questions will be answered in one final venue. As always, thank you guys for tuning in, and I'll see you soon.